question, we have sine equals to sine 3x equals to negative root 3 cosine 3x. Okay, for the domain in between negative pi over 2 pi. So when you see sine and cosine at the same time, a single sine and a single cosine, you will think about tangent. Okay, you will think about tangent. First of all, you will state, okay, sine divided by cos, you will have tangent. So first you will state cosine, can't see it, make it larger, cosine 3x not equals to 0. Okay, you will first state cosine 3x not equals to 0. And then you can divide cosine 3x on both sides. Okay, so you have sine divided by cosine, you will have tangent. Tangent 3x equals to negative root 3. Okay, so now I have changed like sine and cosine into tangent, and it's back to the type of like previous page. Okay, so it's easy to solve from here. And for tangent, we solved sine and cosine last time. And for sine and cosine, unless you have 1 and negative 1, you will have one base angle. All the other values, you have two base angles. But for tangent, okay, tangent equals to anything, you will only have one base angle. Okay, in each period of the tangent, you will learn tangent graph for the next page. But for each period of tangent, when you draw a horizontal line, there will be only one intersections in each period. So in each period, you only have one base angle. Therefore, you only find one base angle from here. The base angle you will work out is in between 0 to pi. Okay, in between 0 to pi. Because when you have the first quadrant value, that is all quadrant, tangent will be positive in here. In the second quadrant is the sine quadrant. You will have negative tangent in that one. So it can cover both cases. So you can find the angle in between 0 to pi to find that base angle. So first we think about tangent, how many degrees equals to root 3? Don't tell me 60, like in reading pi on 3. Okay, tangent pi on 3 will be root 3. But it's a negative. We will find that in the second quadrant because I need the quadrant not belongs to tangent. And I want a reference angle of pi on 3. Okay, therefore the actual angle we're talking about is this green angle here is 2 pi over 3. Okay, 2 pi over 3. So my 3x equals to 2 pi over 3. And the x is 2 pi over 9. Okay, that's the first angle. Okay, that's the first angle. And now let's think about the period. For tangent, what's the period? How we calculate period? Cosine and sine is 2 pi over n. How about tangent? Pi over n. Okay, pi over n. So we have pi over 3 for this case. Okay, pi over 3. Because we have a 3 here. So pi over 3 is the period. And then we will write the general solution. So general solution will be, only have one general solution in this case. For tangent, so 2 pi over 9 plus pi over 3k, where k belongs to z. Okay, I always emphasize that you must write k belongs to z. Okay, always write k belongs to z. Okay, to make an easy calculation, I can say that's 2 pi plus 3 pi k over 9. Okay, k belongs to z. Make a common denominator, and then numerator is easy to calculate. And I want the domain in between negative pi over 2 to pi. Okay, negative pi over 2 to pi. Write it here. So I'll start from 0 as well. Exactly the same way as you solve for sine and cosine, but you only have one base angle. So tangent is always the easier graph and easier solving. K equals to 0, x equals to 2 pi over 9. K equals to 1. X equals to 5 pi over 9. Okay, 3 pi plus 2 pi, 5 pi over 9. K equals to 2, x will be 8 pi over 9. And no space, okay. K equals to 3, x will be 11 pi over 9. Okay, you don't really want 11 pi over 9, so you won't have that one. It's over pi. And remember, you can go backwards. K equals to -1. X will be negative pi over 9. K equals to -2. X will be, again, -6 minus 4 pi over 9. Well, it's still within the domain. Okay, still within the domain. That's 8 pi over 18. Okay, that's 8 pi over 18. And this will be 9 pi over 18. So it's still within the domain, okay? But like, it's really close. You can predict the next one will not really in the domain. So I still need to try it. Let's put it here. K equals to -3. X will be -9, -7 pi over 9. Okay, that's out of domain. Smaller than -pi over 2. So you won't have that one. So your solution will be this much. Okay, solution will be this much. And remember, if in the exam it's not finished, you need to list them. Okay. Okay, I need to show you at least once to make sure you remember that. Okay. Okay, we list that out. X will be these values. Okay, that's your answer mark, the final answer. What's the problem? No? Okay. Okay, that's the first case. Okay, that's the first case. When you have a single sine and a single cosine, and you divide that from both sides. Okay, divide that from both sides. But let's say you need to have a think. Okay, just can't see it. See those values. You need to try to apply that to cosine inside the cosine to see that the cosine will get a 0. No, most of okay, I never see when you get a value really equals to that. But like, you need to have a think about that. If there's any value inside here can make cosine 3x equals to 0, then that value cannot be listed here. Because when you divide cosine 3x on both sides, okay, you can't say that's equals to 0. Okay, you can't have that equals to 0. Okay, most of the case it won't be, but like, it's better to write it down first. Cosine 3x not equals to 0, and then you can divide that on both sides. Otherwise, you can't divide that. Okay, otherwise you can't divide by that. That's the first one, and then have a think about the next one. The next one, you have 2 sine x minus sine x equals to 0. Well, you can equals to 1 equals to 2. Can make it like, looks like a quadratic. So in this question, the type will be, you have square. Okay, you have square of sine or square of cosine or even square of tangent. And another single sine or single cos or single tangent. Okay, you have square of one and like a quadratic. Okay, it looks like a quadratic. But it needs to be the same type. Okay, same sine squared and then sine. You can't be sine squared and cos. That's not the same type. So for this type, you will think about quadratic and you will factorize it. Okay, you will factorize it. If you can really see it, you can directly factorize from here because you can see the common factor sine x here. And then you can take 2 sine x minus 1, like factorize it. Okay, you can factorize like that. Or if you can't see it, or it's hard to see, you can let a equals to sine x. Then what you have is 2a squared minus a equals to 0. Therefore, a times 2a minus 1 will be 0. So it will be the same. Okay, it will be the same. If you can't see it, you can directly factorize using sine. If you can't see it, set up a variable a, and then you solve for a. Well, using non-factor law, if something times something equals to 0, using non-factor law, you will have sine x equals to 0, or sine x equals to a half. Well, it can either be sine x equals to 0 or sine x equals to a half. They both give you 0. So now one question has been split into two. Okay, you need to solve two sign equation. Okay, so it's same again. It backs to the previous page type. Okay, solving for two. Well, that's really basic. Sin x equals to 0, then x will be 0 and pi. Okay, unless you have equals to 1 or -1, you always have two base angles. Even if equals to 0, you still have two base angles, 0 and pi. Okay, 0 and pi, two base angles. Okay. And we have, like, say, general solutions. For this one, your general solution will be 0 plus 2 pi k, or x equals to pi plus 2 pi k, where k belongs to z. Okay, k belongs to z. Well, if you can see these two equations, okay, it's not necessary, but like you can write it into x equals to pi k, where k belongs to z. Okay, it can become a one general solution. Why? Let's see, 0 plus 2 pi k, so it can be 0, 2 pi, 4 pi, 6 pi, 8 pi. Okay, go -2 pi, -4 pi, next to 6 pi. The bottom one, you have pi plus 2 pi k. It can be pi, 3 pi, 5 pi, 7 pi, 9 pi, and going that way will be -pi, -3 pi. So therefore, it's just those two values on the x-axis. Okay, so overall, I can say that just equals to pi k. Okay, just equals to pi k. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and go -1, -2, -3. Not necessary. If you can't see it, it's fine. That's again still correct. If you can see it, you can write in that way. And I can try values. I want -pi to 3 pi. Well, it's quite obvious. If I want -pi to 3 pi, for this one, x just be -pi, 0, pi, 2 pi, and 3 pi. Okay, all the values on the axis. So -pi, 0, pi, 2 pi, 3 pi. Yep, that's the value you will have. And don't forget, you have another side. Okay, you have another side. Sin x equals to a half. Sin x equals to half. Well, if you can't remember, sin pi over 6 is a half. Okay, 30 degrees, pi over 6 is half. And you have two values will be in the first two quadrants. One is here, one is here. Always reference angle of pi over 6. Okay, the first angle is just pi over 6. The second angle will be 5 pi over 6, the larger angle. So your x will be pi on 6 and 5 pi on 6. And you have the general solution, x equals to pi over 6 plus 2 pi k, x equals to 5 pi over 6 plus 2 pi k, where k belongs to z. Well, k equals to 0, x will be pi over 6 and 5 pi over 6. K equals to 1, x will be, that's 12, 13 pi over 6, and 12, 17 pi over 6. Yes. K equals to 2, like you can see k equals to 2 doesn't work. You will plus 4 pi on it. Okay, the limit is 3, like domain is 3. So 4 pi plus something is definitely over. But like you still write 1 maybe, like x equals to, well, 4 pi, like you can write the first one is 4 pi plus pi on 6. Okay, so it's out of domain, you won't have that. And you will go -1. Okay, -1. Well, okay, let me make that clear. When you have k equals to 2, you put the first value here, second value here. And then the first value doesn't work. You directly say, okay, that value doesn't work for sure because it's a value larger than that. When you try -1, when you put -1 into this one, okay, you put the value here. If that one doesn't work, that doesn't mean this one will not work. Okay, so to be safe, maybe you can subtract -1 first into this box. Okay, put the value here. That's the number connected to this one. If that doesn't work, this one definitely not work. But if you put in the first equation, if that one doesn't work, this one still possibly works. So you need to substitute both if you put this one first. Okay, we can just substitute that directly into the second equation and to see what happens. Negative 1, well, it's negative 12, so it's negative 7 pi over 6. Okay, you still have a number here, but I don't need to calculate that because this is already out of domain. Okay, smaller than negative pi already. Then that number to the left is smaller than this one, so doesn't work for sure. So you have another 4 answers here. Okay, another 4 answers here. And remember, I have 5 answers here. So I will write x equals to negative pi. Okay, have 0, pi over 6, 5 pi over 6, pi, 13 pi over 6, pi, 13 pi over 6 is greater than 2 pi, and we have 2 pi, and then 13 pi over 6, and 17 pi over 6, and then 3 pi. Okay, that are the possible values. Write in the order. Okay, write in the order. But well, if it doesn't really in the order, it's not really matters. But it just makes people feel like it's really good. Okay, it looks really good and it's easy to mark. Okay. That's this type. Okay, that's this type, and we have C. Okay, C is a quadratic as well. You only have tangent. Okay, you only have tangent. Well, we have tangent square x equals to 1 over 3. Therefore, tangent x will be, what tangent x will be? If tangent square equals to a third, what tangent x will be? Yeah, definitely square root. But anything else other than square root in the front? Plus minus. Okay, plus minus of square root 1 over 3. Okay, don't forget the plus minus, otherwise it will be the same as a normal tangent question. When you see square, there must be 2 answers. Okay, there must be 2, unless if the square equals to 0. Sine square equals to 0, you only have 1. Otherwise, you always have 2 equations. So you have tangent x equals to positive root 3 over 3, and tangent x equals to negative root 3 over 3. How many degrees will be root 3 over 3? Pi on what? 6. Okay, pi on 6. So for this side is pi on 6. For this side will be 5 pi on 6. Okay, that is the all quadrant, that is the sine quadrant. So you have first one, which is pi on 6, is a positive. And the next one, reference angle with pi on 6, which will be a negative. So you will have 5 pi on 6 for the second one. Okay, 5 pi on 6 for the second one. And what is the period? What's the period for this one? Period? Pi. Okay, period is pi. So you have reference angle. Okay, I can write the reference, not reference angle, the general solution together. I can say that's pi over 6 plus pi k, and this 5 pi over 6 plus pi k. And k belongs to z. Why I do that? Because my solution will be in order. Okay, when I substitute k equals to 1, k equals to 2, solution will be in order. I can do it together. So k equals to 1, k equals to 0. What's my domain? Domain is negative pi to 3 pi. Well, I think it's a lot of solution. Well, x will be pi on 6 and 5 pi on 6. K equals to 1. X will be 7 pi on 6, 11 pi on 6. K equals to 2. X will be, that's 2 pi, 12 pi, 12, 13 pi over 6, 12, 17 pi over 6. That's plus 2 already. And k equals to 3. You plus 3 pi. So pi over 6 plus 3 pi is definitely out of the domain. Okay, domain is 3 pi. So stop here and going backwards. K k equals to -1. X will be, well, -1. We have negative pi. So we have -5 pi over 6. And we have -pi/6. Okay, still within the domain. Domain is -pi. And k is -2. That's one value. I think it's out of domain, so I will directly try the second one. -12. -12 is 7 pi/6. Okay, that's out of domain. So your solution will be 8. Okay, the middle 8. Okay, question B and question C will be the same type. That will be the same type. You always have like something squared, like sine squared minus sine, or like a single tangent squared. They all look like projective form. And you have two equations. Separate that into two equations. Okay, the last type. The last type is give you sine squared and you have cos. Okay, you have both sine and cos in this in the question. It won't be the tangent one because for the tangent for part A, you must have one sine and one cos. Just want to mention another thing. Okay, see part 1, sine and cos are on different sides. Well, if I have sine x plus cos x equals to 0, like something like that. Okay, first thing you need to do is separate that into two sides. So I have sine x equals to minus cos x, and then divide cos x on both sides. You have tangent x and there's a number on that side. Okay, so just make sure like you know you separate that first and then divide by it. And for D, you have sine squared and cos. Even though you divide by cos, you won't have tangent. Sine squared divided by cos will not be tangent. So we'll use Pythagoras identity. Sine squared plus cos squared equals to 1. Okay, sine squared can always convert into cos. Cos squared can always convert into sine squared. So now like I will change the square term because sine squared plus cos squared equals to 1. So I will have 2 times 1 minus cos square x plus 3 cos x minus 3 equals to 0. Okay, so now everything will be cos. Okay, everything will be cos. You have minus 2 cosine square x plus 3 cosine x. Okay, you have a plus 2 in the front. That's a plus 2. Minus 3, you have minus 1 equals to 0. Well, if I say a equals to cos, that's 2a squared minus 3a plus 1 equals to 0. Okay, I minus both sides. Minus both sides. 2a squared minus 3a plus 1. Okay, 1, 2, minus 1, minus 1, minus 2, minus 1 is minus 3. So it's a minus 1, 2a minus 1. That equals to 0. Okay, factorize it. 2 can be changed into 1 to 2. 1 can be minus 1, minus 1. Cross multiply. Minus 2 plus minus 1 is minus 3. And I can factorize that into this form. Okay, cos x equals to a. Okay, it's easier to see by using the term a. And now I will have cosine x equals to 1 or cosine x equals to a half. Cos x equals to 1, cosine x equals to a half. Okay, now you have 1. Okay, you have 1. So 1 is the maximum value. I will only have 1 base angle. So the 1 base angle will be what? Cosine what equals to 1? 0. Okay, cosine 0 is 1. So the answer will be, the general solution will be 0 plus 2 pi k because the period is 2 pi. So x will be 0, 2 pi. Okay, only 2 solutions because the period is in between 0 to negative pi to 3 pi. Okay, negative pi to 3 pi, so 0 to pi. For the other side, okay, a half. Okay, positive a half. Positive a half. Cosine, how many degrees is a half? Pi on 3 is a half. So I will have all quadrant and the cosine quadrant. So I have pi on 3 in those 2 quadrants. I want the reference angle to be pi on 3, reference angle to be pi on 3. But the actual angle we're talking about, first one is pi on 3, the second one is 5 pi on 3. Okay, the big angle here, 5 pi on 3. I always count the angle in anti-clockwise. Okay, I always want positive. I don't want to go that way. I can also say that's a negative pi on 3. Okay, I can also say that's a negative pi on 3. But I don't really like it. I want to go all positive direction. And then x will be pi on 3 and 5 pi on 3. So general solution will be x pi on 3 plus 2 pi k. And x equals to 5 pi on 3 plus 2 pi k. So you have k belongs to z. K belongs to z. K equals to 0, x equals to pi over 3, and 5 pi over 3. K equals to 1, x equals to, that's 6 pi over 3. 6 pi over 3, 7 pi over 3. And that's 11 pi over 3. And the next one, you know that will be out of domain because x will be pi over 3 plus 4 pi. Okay, 4 pi is too big, can't be that one. And remember, go to the negative direction. K will be negative 1. X will be, I think it will be out of domain, so I'm not calculating the first one. Calculate the second one. Negative 1, negative 6. Well, it's still, no, let's calculate both. That's negative pi over 3. Okay, that one is negative pi over 3. And the other one is minus 6. So minus 5 pi over 3. This one is out of domain. Okay, can you see the second one is not, but the first one is out of domain. It's negative 5 pi over 3. It's negative, again, smaller than negative pi. And therefore, I have 5 solutions in this one. Okay, 5 solutions in this one. And you have another 2. Yes. Yeah, I want 3 pi. Yeah, this one is out of domain already. Shouldn't try that one. Shouldn't try that one. That's out of domain. That's out of 3 pi. It's almost 4 pi, so I can't have that one. So yeah, 4 solutions here. 4 here, and plus the other 2. So you have x equals to negative pi over 3, 0, pi over 3, 5 pi over 3, 2 pi, and 7 pi over 3. Okay, in this exercise, in this page, we have some square form, like quadratic form, circular functions, have sine and cos. We want to make it into tangent, so we have another 2 types of question. Okay, 2 types of question. So that's the solving you have in year 12. But it's not really something hard. Let's go through the tangent graph. Okay, so when we sketch tangent graph, it's not that difficult than sine and cosine graph. Okay, I like tangent graph a lot because tangent graph is just really follow some steps and finish. So for sine and cosine graph, we'll find the starting point first, and then we think about the step length. So each step, how much it will take, and then complete the pattern. for cosine tangent graph, so the first thing we want to do is find the first two asymptotes. Okay, first two asymptotes around the x-axis. Not necessarily around the x-axis. You just find any two adjacent asymptotes, and that's it. Okay, so how do we find asymptotes? First, tangent what is undefined and tangent what is undefined. There are two values in first cycle 0 to 2 pi. There will be two values which is undefined. Which two? Tangent what degrees is undefined? Pi on 2 is here. Yeah, 3 pi on 2. Okay, two values. Because cosine pi on 2 will be 0. Cosine 3 pi on 2 will be 0. So you can't divide, sine divided by cos, you can't divide it, it's undefined. So those two values undefined, which is one angle here and one angle here. Like if you go positive direction, it's pi on 2 and then 3 pi on 2. But if I go negative direction, I can say that's negative pi on 2 and positive pi on 2. Okay, I can say that's the first two. I can say that's the first two. So that value is undefined. There's asymptotes in tangent. Why there's asymptotes? Because it's the value undefined. Okay, so I want to make the bracket. Okay, something in the bracket. First, equals to plus minus pi over 2. Okay, first equals to plus minus pi over 2. That's find asymptotes. Okay, that's how we find asymptotes. Make the first two. Minus pi on 2 and pi on 2 must be the two adjacent asymptotes. So I make that equals to plus minus pi on 2. That's the adjacent asymptotes as well. Okay. I just almost finished. Yeah. So we can solve x equals 2 plus minus pi over 4. Okay, that's the first two adjacent asymptotes. And let's sketch it here. Let's sketch that here. Plus minus pi over 4. And we can find all the rest asymptotes, or the rest of the asymptotes. Why? Because all the asymptotes will have the same, like it's the period, it represents the period. The period will be pi over 2. Okay, the period will be pi over 2. So the next asymptotes will be pi over 2 units away from that. They all have the same distance, okay, equal distance. So the next one will be here. Okay, next one must be here with the same distance. That's pi on 4, that's 3 pi. Here is 3 pi on 4. So already reach the domain. So 3 pi over 4. And go to the left hand side. You have one here. Okay, that's negative x equals to negative 3 pi over 4. That's x equals to negative pi over 4. X equals to pi over 4. And x equals to 3 pi over 4, which is negative 3 pi over 4. 2 pi over 4 is within the domain. Okay, I find all the asymptotes within the domain. Okay, that's the first step. The second step is find your point of inflection. Okay, point of inflection will be in the middle of the asymptotes. Okay, point of inflection must be the middle. And then we can see there's a plus 1 at the back. It will be the midline. Okay, shift your point of inflection 1 unit up. So you will sketch at 1. You have a line here. Well, you not necessary to sketch it. I'll just tell you your point of inflection will be here. Okay, your point of inflection will be here, and also in the middle. Okay, in the middle. So where is the point of inflection? Here, here, and here. Okay, that's the middle. You can see the box. Okay, they are all in the middle. That's the second thing. Find your point of inflection. Okay, first make sure you midline, and then all the point of inflection will be on the midline, and then label the point of inflection. The last thing you will think about is whether it's an increasing graph or decreasing graph. Okay, you know what the tangent graph looks like. It either looks like that or looks like that. Okay, you need to make sure which direction it looks like. So you see two places. Okay, two places. First is the number in front of the tangent. Second is the number in front of x. Two places. Okay, one is the number in front of the tangent. One is the number in front of the x. Okay, one is make reflection in the x-axis. One is make the reflection in the y-axis. Okay, that's make reflection in the x-axis. That's make reflection in the x-axis. That's in the y-axis. That's in the x-axis. If both positive or both negative, okay, both positive or both negative, increasing graph. One positive, one negative, decreasing graph. Okay, doesn't matter which positive, which negative. If one positive, one negative, decreasing. Okay, both positive or both negative, increasing. So this is a definitely increasing graph. We have both of them positive, both of them positive. Therefore, my graph will look like that. Okay, parallel to the asymptotes. Okay, your end must be parallel to the asymptotes to show it's approaching, but never touch. I can take off the red line and label the points here. That's negative pi over 2, 1. This point will be 0, 1. This is pi over 2, 1. And label all the asymptotes. I can't find exact value for the x-intercepts because tangent x equals to 1/5 is not exact value. So I don't need to worry about the intercept. Okay, I don't need to worry about the x-intercept. So tangent graph is easy. Find the asymptotes, first two pair of asymptotes, and find all the rest of the asymptotes within the domain. Okay, and second, find the point of reflection. Okay, point of reflection will sit on the mean line. Number 3 is make sure the shape of the graph, that is increasing graph or decreasing graph. If the two numbers are both positive, increasing, or both negative, increasing. One positive, one negative, decreasing. And make sure you label all the asymptotes and make sure you label all the point of inflection. Okay, next one. Okay, I'll solve the last one. Okay, pi over 2x, okay, in the bracket, pi over 2x in the bracket. I want pi over 2x first equals to plus minus pi over 2. Okay, plus minus pi over 2 is the value tangent cannot take. Therefore, that must be the asymptotes. Okay, so x will be equals to, okay, plus minus pi over 2 times 2 over pi. X will be plus minus 1. Yeah, x will be plus minus 1. So we have that's minus 1, that's plus 1. Okay, the distance between them is 2. Okay, the distance between them is 2. So the next one will be 3. Wow. Come on. Come on, come back. There, just wait a moment. I think it's not working. Well, the next two asymptotes will be 3 and 5, and the negative side will be negative 3 and negative 5. Okay, make sure you label that. Come back. Yes, good. Okay, negative 3. and 5. I think domain is 5. And you have -3 and -5. Okay, and we will have midline is on -3. Okay, here is the midline. And then the middle point will be this point, this point, this point, this point, and this point. Okay, 5 points. And I need to label the, think about the shape. Okay, -1, x is 1, x is 3, x is 5. Decreasing or increasing? Decreasing, because one of the number is negative. Okay, this one is negative, this one is positive. Decreasing shape. Okay, decreasing shape. So you will sketch the graph like that. Well, they are quite identical, so try to sketch it like really identical. Like that. Not like that. Okay. Last thing is whether we can find the x-intercept or not. Okay, that's -4, -3, -2, -3, 0, -3. 1, 2, -3, and 4, -3. We have -3 tangent pi over 2x, -3 equals to 0. Because I want to y equals to 0, so for the x-intercept. Therefore, tangent pi over 2x equals to -1. Plus the 3 divided by the -3, you have -1. Okay. Tangent pi over 4 gives you 1. You want -1. -1 will be here. Okay. In the second quadrant. So pi over 2x needs to be 3 pi over 4. Here is pi over 4. You want the other side, 3 pi over 4. X will be 3 pi over 4 times 2 over pi. Okay, that's 1, that's 2, the 2 pi's cancelled. X is 3 over 2. Okay, X is 3 over 2. Period equals to pi divided by pi over 2. Okay, if you can't see the fraction form in that way, you can't calculate that in that way, you will write pi divided by pi over 2. That equals to pi times 2 over pi. And you will have period equals to 2. You also see that already in the asymptotes. The distance between asymptotes is the period, and it is 2. Okay, and it is 2. So, okay, instead of write the general solution, I would directly write like general solution is x equals to 3 over 2 plus 2k. Okay, there's no pi. It's period times k. K belongs to z. Okay, 2k. So if I have the first point is 1.5 here. Well, my label is not really good. You need to adjust that. Let's say 1.5, 0, 3 over 2, 0. And then the next one you plus 2 is 7 over 2, 0. Okay, and go to the left, minus a half, 0. Minus 5 over 2, 0. minus 9 over 2 comma 0. Okay, keep subtracting or adding 2 on it. Okay, keep subtracting or adding 2 on it. Okay, what the first point you know is this point here. Okay, this point here. And then you are adding and subtracting points on it. Subtracting or adding 2. Okay, so we quickly go through tangent graph and tangent solving today, and your homework will be page 14. Okay, solve 2 questions on page 14. Okay, that's it for today.